Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Rafi'i. The title of Lab 4 is RLC series and parallel circuit. The first activity is steady state behavior of RLC series circuit. In activity 1, there are 9 components consist of voltage source, ammeter, voltmeter, 3 voltmeter, a resistor, a inductor, and the last one is a capacitor. Then we will connect each other to be in one circuit. The voltmeter will connect in parallel with resistor, with inductor, and with the capacitor. The value of resistor we will use 100 ohm. The value for inductor we will use 50 millihenry. The value of capacitor we will use 16 microfarad. We will set up the ammeter AC. This one voltage AC. This one also voltage AC. And this one also voltage AC. And this one we will measure power. According to the table 5.2, we will measure voltage 10 volt, voltage source. We will use 50 Hz. Then we will run it. The current here we will get 48.044 milliampere. The power here we will get 230.8295 milliwatt. The voltage here we will get 4.804. The voltage here we will get 757.109 millivolt. And the voltage here we will get 9.527 volt. Then we will change to the 20 volt. The current here we will get 96.088 milliampere. The power here we will get 923.3 milliwatt. The voltage here we will get 9.609 volt. The voltage here we will get 1.514 volt. And the voltage here we will get 19.055 volt. I will change the voltage source to 30 volt. The current here will get 144.132 milliampere. The power here will get 2.077 watt. The voltage here will get 14.413 volt. The voltage here will get 2.271 volt. And the voltage here will get 28.582 volt. The voltage source we will run it until 100 volt. Last but not least, when the voltage 100 volt, voltage source 100 volt, the current here will get 480.441 milliampere. The power here will get 23.083 watt. The voltage here will get 48.044 volt. The voltage here will get 7.571 volt. And the voltage here will get 95.273 volt. The power factor for the circuit is 0.48044. And that's all. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Now I'm going to present and demonstrate for the circuit for activity 1 for table 5.3. So the circuit is same as from table 4.2. As we know, we got here voltage as the source, 3 voltmeter, 1 ammeter, 1 power wattmeter, 1 resistor, 1 capacitor, and 1 inductor, and 1 ground. So now I'm going to show how to connect all of these components according to the circuit that we had that been given in the lab sheet. So for the voltage source, we'll go to the positive. For the ammeter and the negative side from the wattmeter, we'll go to the positive. We'll go to the positive wattmeter at the volt, and then the output current from the wattmeter will go to the capacitor. This capacitor will connect into the resistor. A resistor will connect to the inductor. Then from the inductor will connect to the ground. Will connect to the ground. Alright. So for the wattmeter, negative from the voltage will go to the positive side. Sorry. This negative from the voltage will go to the ground, and then the positive side will go to the positive from the current side will go to the voltage. Wait, now for this voltmeter, 3 voltmeter, each one is for the 3 type component. So for this XMM3 volt multimeter, I have been set to the voltmeter SE. Now it's going to calculate for the it's going to measure the value for the capacitor. For this voltmeter will measure the value for the resistor, and then this last one voltmeter is going to measure the value for the inductor. Alright, so this voltmeter also I set to the SA ammeter and SC. Alright, now I'm going to change the value for the source and these 3 types components. Now for this, according to the table 5.3, we start with 10 volt, and then the frequency is 50 hertz. Okay. Now for these three type, for the first one, capacitor is 16 microF. For the resistor, for the table point 3 is 50, and the last one is 50 mAh. Alright. Now I'm going to run this circuit and show this all value for the first 10 voltage source. Right? Then I click this, it will show the result. This for this, and this. Alright. Okay, for the 10 volt source, for the emitter we got 52.835 milliampere, and for the wattmeter we got 139.7576 milliwatt, and for the voltmeter for capacitance, it means VC, we got 10.477 volt. For the VR voltage resistor, we got 2.642 volt, and then the last one for voltage for the inductance, we got 832.6 millivolt. Now I'm going to start running, and I will show for the second voltage source is 20, and the value for each. Alright, now I'm running. Then for the 20 volt, we got for the emitter is 105.669 milliampere, and then for the wattmeter we got 558.303 milliwatt. For the VC we got 20.955 volt. For the resistor we got 5.283 volt, and the last one for the inductor is 1.665 volt. Alright, now that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Rafi'i. We will going to the next activity 2, experiment A, which is steady state behavior of RLC parallel circuit. There are 9 components in experiment A, which is consists of voltage source. There are 4 emitter, 1 wattmeter, a resistor, a inductor, and a capacitor, according to the lab sheet. We will connect each other component to make a circuit based on experiment A. Resistor, inductor, and capacitor will connect in parallel series with emitter and emitter. Okay, now we will change the value of voltage source, which is following the table 5.4. We use 50 Hz. The value of resistor we will use 50 ohm. The value of inductor we will use 100 milli. The value of capacitor we will use 28 microfarad. Then we will set up the emitter that we will use. Emitter and AC. We will run it. The value of emitter here we will get 304.5 0.068 milliampere. The power here we will get 2 watt, and power factor we will get 0.65774. The value for ammeter here we will get 199.999 milliampere. The current here we will get 317.286 milliampere, and the current here we will get 88.248 milliampere. We will change the value to 20 volt. 20 volt, 50 hertz. We run it. The current here we will get 608.135 milliampere. The power here we will get 8 watt, and power factor we will get 0.65774. The current here we will get 399.998 milliampere. The current here we will get 634.571 milliampere. The current here we will get 176.496 milliampere. We will change voltage source to 30 volt. 30 volt and 50 hertz. We run it. The current here we will get 912.203 milliampere in AC. The power here we will get 18 watt, and the value of power factor 0.65774. The value of current here we will get 599.998 milliampere. The current here we will get 951.857 milliampere, and the current here we will get 264.774 milliampere. Then the voltage source we will proceed until 100 volt and 50 hertz. Okay, last but not least, the last voltage that we will predict is 100 volt and 50 hertz. We will run it. The current here we will get 3.041 AC ampere. The power here we will get 200 watt, and power factor 0.65774. The current here we will get 2 ampere AC. The current here we will get 3.173 ampere AC. And the last one, the current here we will get 882.48 milliampere. Thank you.